Hey, Vlad here, devinside.com. Welcome to another video. In the previous video, we have been introduced to streams in a very abstract and you could say crazy fashion. And so today we're going to have a simple hands-on example, and because there was too much blah blah in the previous video, I'm just going to shut up and start writing some code instead. As always, we're in the fully maximized Ubuntu virtual machine, and we're running Sublime Text, which is also fully maximized, which is the editor of my choosing. And we're also using a wonderful plugin called Terminus, which is down here, which allows us to emulate the entire terminal for us, which we use to run SBT, which usually reruns the test every time we save the file. But as I already said, today we're just going to have a simple main method, which we're going to rerun every time we save the file. And also my seemingly endless fight for more screen space continues. And so I tweaked a few things here and there. For instance, I found a Sublime setting, which lets my scroll bars disappear, and so every time I scroll they appear for a bit and then they disappear again. Also found a cool Windows tool which makes my mouse cursor disappear so that the code that I'm writing is actually more visible. It should also disappear every time I type, but because I'm typing inside of the VM, the Windows tool does not get an event, but you know, it's better than nothing. Also, I changed the way I'm recording my screen a little bit, so if my face is covering something up, like in this case, I can make myself transparent or even completely invisible and then reappear later in the video, which takes a bit longer to edit the video, but I believe you guys are worth it. All right, let's get right to it. So what we're going to do today is we're going to have a super simple example, and we're going to write it in a very straightforward imperative way. Then we're going to rewrite it with IO, and then we're also going to rewrite it with streams. And as you will see, streams are super fun to work with, but annoying, and I really mean annoying to implement in a language like Scala, because a language like Scala uses the applicative order of evaluation, and streams come from a completely different world of normal order evaluation. But we're getting ahead of ourselves. Also, I made videos about these a long time ago. I'm going to have a link somewhere here so you can check it out if you feel lost. All right, let's begin. So I'm going to create a file and I'm going to save it right away. I'm going to call it playground.scala. And if I reveal it in the sidebar, you will see that it's in the same folder as everything else. We don't need the test today. So it's in source main Scala Homegrown Collections, where the rest is. Okay, so we have our playground, and also I'm going to close the set. We don't need it anymore. Okay, so I'm just going to say package Homegrown Collections, and I'm going to have an object playground. It extends app. And we're going to have a tiny helper today, which I'm going to call run. So we're just going to give it a name parameter with some code, and it returns a unit. And all it will do is print line my favorite hyphens, which is -u 2500 times 50. And we're going to have it twice like this. And in between, it's just going to run our code. So for instance, we can go over here and we can say run print line hello world. Let's see. So it's going to rerun our tests. And for some reason, it takes forever to compile. Come on. There we go. Okay, so now let's do a run main, Homegrown Collections, playground, and there we go. We see our hello world. Let me also copy one of my hyphens like this, put them over here like that, and save it, and there we go. All right, so let's start with a super simple program. So instead of hello world, we're going to say what's your name, and then we're going to capture the name in a string, which is going to come from Scala IO standard in read line like this, and now we're going to print out a string interpolation over here. I'm going to say my name is name dot like this, and let's see, and I can just put in Vlad over here, enter, my name is Vlad. Cool. So the next thing I'm going to do is I'm going to import scala.io.standardin.readline, because we're going to work with it quite a bit today. So let's do this like that. There we go. What's your name? Still Vlad. My name is Vlad. Awesome. Okay, so now this takes forever, so I'm just gonna instead of read line, I'm just gonna put Vlad over here. There we go. So it just runs real quick like that. All right, so the next thing that we're going to do is we're going to run it a few times, because this kind of program is kind of boring. So I'm going to copy that, I'm going to comment it out, I'm going to go down over here, I'm going to paste it again like this, and we're just going to build a while loop around it. So we're going to have var, which is a looped times variable, and then I'm going to say while loop times less than 2, because we want to run it 2 times. Open brace over here, our brace over here, and let's not forget to do loop times plus equals 1 like this. Let's also scroll down a little bit. There we go. So now it runs twice. For some reason the font feels kind of small. I'm going to increase a little bit. Yeah, I think that's better. Not sure why it feels so small all of a sudden. All right, so in the monad series we talked about the IO monad, and if you skipped it, don't worry. All we need to know is that it's just a tiny wrapper around a thunk. So this is a thunk, right, which is just a function that starts with basically an empty parameter and returns an A, right? And the IO is just a wrapper around a thunk, so it's going to be called unsafe run, and it's just a thunk of A, which comes over here plus A like this. Okay, now we will also have a tiny helper over here, which is going to create IOs. So it's going to be called pure. It's going to get an A, which is going to be a by name parameter like this, and it returns IO of A, which just does IO, and then it passes a thunk like this. And if you haven't seen my video about monads, really don't worry about it. All you need to know is basically IO allows you to convert your program into a description of the program that essentially in the end of the world is going to be interpreted by your main method. That is all that you need to know. Now, as I mentioned in the beginning of the video, since Scala, as most programming languages, uses the applicative order of evaluation, we need to be careful that we don't leak unnecessarily initialization. And the same as in the monads videos, we're going to use colors to help out with that. So we're going to go to our playground, and as the very first thing that we're going to do is we're going to print, not print line, just print console.red. And we'll also have a tiny helper for IO. So we're going to have run IO, which is going to get an IO, which is going to be an IO of any, and we'll return a unit, and all it will do is just run IO.unsafe run like this. Okay, so now the next thing that we're going to do is we're going to use two more colors over here. So over here in run, we're going to do print console.green, and over here let's actually clone this line and go down over here. Let's do a reset like this. Okay, so what we can do now, as you can see, everything is green because we're still using the imperative program. So let's comment this one out like this. Let's create a completely new one actually down there. We're going to call it run IO. So instead of calling run over here, we're going to call run IO that we just created. So we do run IO. Okay, and we're going to have a print line. So this one should be red, and then over here we're going to have IO pure like this, and this will print line should be green. Okay, so this is essentially what our colors will help us with. So if you make a mistake, we should see red, and if everything is inside of IO somehow, then it should be green. Okay, so now we can implement the same thing as we have over here. Let me just copy that thing. Let's throw it in over here, right? And remove that and comment that. So now that it's inside of IO pure, it still should be green. Everything is cool. Now obviously this is not functional enough, and as we have learned in the monad series, IO has a monad, and therefore we can go and implement map and flat map so that we can use our for comprehensions. So our map is going to look like this. It's going to take a function from A to B, produces an IO of B, and it's going to be IO pure, right? Then it's going to get the A from calling unsafe run like this. Then it's going to get the B from calling AB by passing it the A, and then it's just going to return the B. And the next thing that we're going to do is we're going to implement flat map. It's flat map like that. It looks basically the same, but it's not a function from A to B. It's a function from A to IO of B like that, IO of B, but it also produces IO of B like that. Let me scroll down a little bit. All right, so the implementation is going to be very similar. It's going to be IO pure like that. Don't want that empty line like this. So we're going to get an A same way by calling unsafe run. Then we're going to get IO of B by calling A IO of B by passing it an A. And then we're going to get a B by doing IO B dot unsafe run, and we're just going to return the B. This is our map and flat map, and so now we can go and re-implement our code over here. I don't want to comment it out. I want to just go over here and put a full comprehension in there. So what we're going to do is we're going to create a val over here. I'm going to call it inner IO, which is an IO of unit like this, and it's going to be equal to 4. Then this entire thing is going to be inside of a 4, in fact, this thing as well. And then in the end, once we're going to finish writing the for comprehension, we're just going to say inner IO dot unsafe run. So what we're going to do over here is we're going to say that an underscore comes from IO dot pure, wrapping this print line. Then the name, which is a string, we don't need the string anymore, like this. It comes from IO pure of Vlad, which we also can, we can put the read line in here. Then the next underscore is going to come from over here. It's going to be io.pure print line like this. And the last underscore is going to come from here, io pure loop times plus equals 1 like this. And we're just yielding an empty scope like this. And we don't need, no, hold up. No, that's good. That's good. Okay, no, it's all good. Okay, let's see if it compiles. If I made some typos somewhere. No, I didn't. And this is easily the ugliest code that I have ever written. So let's just rewrite it with a def instead of a while. So we don't need to do this inner IO thing. We can just throw all of this out like this. And over here, the while is going to become an if. And this thing is just going to return the entire for comprehension like that. And so this whole thing will be wrapped into, let's remove that. It will be wrapped into a loop, and we're going to have looped times, which is integer. It's just going to return an IO of unit, and it equals this whole thing. And otherwise, it will just return IO of pure like this. And so we don't need to create this whole IO pure ourselves. We're just going to call loop down over here like this, and we're just going to call it with 0. Let's see if I made any typos. Of course I did. And it looks like the typos over here. We don't need this curly brace. It should be actually down there probably. No, too much. Hold up. Like this. Obviously that should just say plus like that. Now it runs only once because I forgot actually to call loop. There we go. Like this. So now it runs twice, the same as before. Now it's good practice to have a shorter if than the else clause. So we better invert this. So if it's 2, then we're going to have IO pure, and otherwise we're going to have the for comprehension like this. All right, let's see. Yep, there we go. Also, it's more common to move the entire if expression into the last clause over here, so we can do that as well. So we're just gonna cut this out, and we're going to put it over here, right, like this. So if it's 2, then pure. Otherwise, loop times plus 1 like this. But I believe in this case, we should actually start with 1. Let's see. Yep, there we go. Now, this is relatively readable if you're used to this programming style. We're also going to have a few helpers. So we're going to have a read over here, which is just going to be IO pure of Vlad in this case. And we're going to have a write, which is going to be input of any like this, which is an IO of unit, which is IO pure of print line input like this. And so now we can, instead of this, we can just say read, and instead of this like that, we can just say write and go to the end and do that. Let's see, not wrote, write like this. All right, same thing. All right, so now let's see how we can do the same thing with streams, which we don't have yet. So in the beginning, let's actually take IO and put it into its own file like this. So we're going to cut it out. I'm going to create a new file. I'm going to call it io.scala, and we're going to paste it in. I'm going to go to the top. I'm going to say that it's still in the package homegrown collections, and in Scala 3 you can have a type flying around in scope on its own, so it doesn't have to be inside of a class or an object. In Scala 2, which we're still using Scala 2.12, we could put into the package object, but because we're using it only once, we're just going to throw this out, right? So we can't have this type over here. So instead of a thunk over here, we're just going to have that like this. Okay, that should actually be enough. So IO now is in its own file. It's just a tiny factory. It has map, it has flat map. We're going to go back to playground like this. It's still working. Great. So the next thing that we're going to do is we're going to actually create our streams. And because I really like this timeline metaphor, we're actually going to call it timeline. So we're going to create a new file. I'm going to call it timeline.scala like this. Package homegrown Collections, and there we go. If I save the file, it should probably bark at us that we don't have anything inside. Yep, it doesn't like that. Now, the classical stream encoding begins with a typical single linked list implementation. So we're going to have a sealed abstract class, which is a typical list. We already have lists, so I'm going to call it typical list. It has some element, and we're going to have an object, which is a typical list, and it's going to have a case class in there, which is going to call non-empty. And it's parameterized with plus element like this, and it's going to have an element, which is an element like that, and other elements, which is a typical list of element like that, and it extends typical list of element. And we're also going to have a case object empty extends typical list of nothing like this. Okay, so this is a typical implementation of a single linked list. Now, the difference between a list and a stream is that at least the tail is delayed. You sometimes see implementations where only the tail is delayed. We're going to have an implementation where the element is also delayed. And how are you going to delay things? Well, with a thunk. So both of these, they can be by name parameters like this. In fact, with by name parameters, they're actually not going to compile because it's a case class. But I believe if you make them something like private this val, then maybe it's going to work. No, val can't be this. Private this, no. Yeah, so basically with a case class, it doesn't really work. So that's going to be element and other, come on, other elements like this. Okay, so these could be thunks instead, like this. And in fact, what we're going to do is we're going to use I/O instead, because for I/O we will need to write more code, and it's going to be more evident if we accidentally leak initialization. So instead of thunks, we're going to go straight for I/O. So this is going to be I/O of element, come on, element, and okay, like this, and like that. Okay, and since we're going with this whole timeline metaphor, I'm going to start renaming things. So this typical list is going to be called timeline. And this one is going to be called and, because it's going to be the end of the timeline, end of time. I'm not sure how we should call this one. I'm going to keep it calling non-empty, and then I'm going to call this one. First of all, I'm going to call element. It's going to be called event. Okay, and this one is going to be called recent event, and this one is going to be called previous events, because remember, the same as lists, they're built the same way as stacks, and so you start with the last thing, so to say. All right, so let's throw this one over there, and we actually don't need I/O for now. So let's go to playground, and let's start implementing this with streams. So I'm going to do this like that, and I'm going to do run instead. Run. Let's see, it should be empty. Yes, okay. So we're going to have a run, and the first thing we're going to do is we're going to create a timeline of strings, which is going to be a timeline with only one event. So it's going to be a timeline dot non-empty, and we're going to say that the recent event is IO pure of Vlad, and sorry, comma over here, and the previous events is going to be IO pure of timeline.end, right? So there's only one event in this whole thing. Let's see if it compiles. Yes, it does. All right. So now what we're going to do is we're going to do a print line. What's your name? Like that. And now we're going to retrieve the name, right? So it's going to look like this. So it's going to be an optional name, which is an option of string. I was trying to annotate the types when I'm recording videos. Okay, so we're going to go to read, okay, and we're going to match on it. Okay, so we're going to say if it's a timeline dot end, then it's going to be none. Otherwise, if it's a timeline dot non-empty, then this is going to be the recent event, and we don't need all the other events in this case. Okay, so we're going to do that, and then it's going to be a sum of recent event, and now we need to initialize it, right? So we call unsafe run like this. So this one forces evaluation, which is not how you would usually program with streams, but we're just in the beginning, so we're just getting started. Okay, so this is our optional name, and it compiles. So now we can go over here and we can say name, which is a string, is an whoops, I forgot the equal sign. It is an optional name, get or else sys.error should not happen like this. Okay, so this is our name, and now all we need to do is we need to print out the same string interpolation as we have it above, which just says my name is name like this. Let's see, it's exactly the same program as before, but we don't have the loop yet, and we're going to do this soon. Now, if you take a closer look at this one, then this is actually exactly how we implemented had on list, and our timeline is also going to have the had. So I'm going to copy that. I'm going to go over here. I'm going to go into the timeline over here. I'm going to paste this in, and it's going to be a final dev had. It's going to be an option of event, and it's going to be not read match, it's going to be this match. So if it's end or timeline.end, so let's just do this, end, none, and otherwise if it's not empty, then it's going to be some recent event unsafe run. So in order for this to compile, I'm just going to import timeline like this, because we're now just using end and non-empty like this. Let's see if it compiles. It should. Okay, yeah, it does. And now instead of optional name, we can just go over here and we can just say read.had. Okay, and now we don't need the optional name. All right, so the whole thing is a bit shorter, but still, this is not like the way you would typically work with streams. Just to be clear, had actually forces evaluation. All right, and by the way, for the symmetry, let's also implement tail. So let me copy that. Oops, copy that. I don't think that we're going to use tail actually, but let's implement it because we can. So it's going to be a timeline of event, and we're going to do this match case end. Then it's also going to be end, and if it's not empty, in this case, we actually don't need this one. We actually need the previous events, and so it's going to be previous events dot unsafe run. We don't need to wrap it into sum like this. There we go. It should compile, I believe. Yep, it does. Cool. All right, now let's start doing something more stream-like. First, we're gonna copy our helper back for write, because since we already have read, we should also have write like this. Paste it in, uncomment it. There we go. Refactoring, perfect. So instead of this, I'm gonna comment it out for now. What we're gonna do is we're going to create a timeline, right? So we're gonna create a timeline, which is going to be a timeline of unit. Right, similar to IO of unit. Okay, so this is going to be a timeline of unit, and we're going to implement it in a few seconds. And then in the end, what we're going to do is we're going to force evaluation by doing timeline for each. And for each, so this is going to be an event, and it's an event of unit. So all we need to do is we need to touch it, right? So we can just do this, right? Or basically, you know, the identity function. All right, so this line will actually evaluate the entire timeline. I'm going to comment it out for now so that you see that nothing is happening until we actually call for each. Okay, like this. Okay, so let's implement the timeline, and I'm going to try to do this very, very slowly. So this timeline is a timeline of non-empty, in which the first event, right, the recent event, is going to be write, what's your name? Right, this is the first thing that is happening. What's your name? Okay, what about the previous events, comma, previous events? Okay, so the previous events is going to be IO pure of some big code. Okay, so what are we going to have over here? Well, relatively the same thing as we had before. So we called had, but even before that, I actually don't have it anymore. We actually pattern match on the read. So we're going to do a read match, and we're going to do the same thing, you know, relatively the same thing as we're doing in the had. Maybe I should show it over here. So this is the had over here, right? So we're going to do case end. And then, in fact, I have to do timeline.end. Then it's going to be timeline.end. So in this case, the timeline that we're creating is also going to contain only one event. So we're not doing this loop yet. We're just doing it once. Okay. So it's going to be timeline end. And otherwise, if it's a timeline dot not empty with recent event, and we don't need the tail again because it's going to be a single timeline. A timeline was a single event, I'm sorry. Okay, then in this case, again, we need to produce another timeline, so we're going to do non-empty. I'm going to say that the recent event is another write. Okay, this is the part with the stream interpolation. I'm actually going to copy it from over here, right, like that. But we don't have this variable name. Let me create a bit more space like this. We don't have this variable name, but we have the recent event. So we're going to do over here recent event dot unsafe run. Okay, like this. Okay, cool. Notice that this thing is actually not running, right? Because we're inside of write. Write is just a helper that will create an IO for us. Okay, so we're not leaking initializations over here. Okay, so this is the write, and we need the previous events. Previous events is going to be IO pure of timeline dot end, like this. So if I don't have any mistakes over here, it should compile, but it doesn't do anything again, right? Because it just creates a timeline, which is just a just a recording of a bunch of events. But unless we actually go and touch them, nothing is going to happen. So we actually need to call this for each, which we don't have yet. So let's go and implement for each, which is the same as for most of the collections that we have implemented so far. So we're just going to go over here. I'm going to say final def for each of result, It's going to be a function that will take an event, produce a result. It's going to return a unit, which is going to be this match case end. Then just don't do anything. And if it's a case not empty with the recent event and the previous events, arrow to the right, then we're just going to call this function with the recent event dot unsafe run, which is the initialization leak, which in this case is not a leak. This is exactly what we want. And we're going to do the same thing for the previous events. So previous events unsafe run, right? So this was an IO of a timeline, unsafe run. Now it is a timeline. And on that timeline, we're calling for each again, and we're passing in exactly the same function. Let's see if I made any typos. It looks like I didn't. Okay, so now we can go over here and just do that, and now it will run the same as before. It runs only once because we're ending it after doing one thing. So what we're going to do now is we're going to scroll all the way to the top where we have run IO, and now we're also going to have run timeline, which is just going to call for each for us. Okay, run timeline. This is a timeline of any, and this thing returns a unit, which just is going to take, it's just going to call run with timeline dot for each identity like this. Okay, so now at the bottom, instead of calling, we actually don't need this anymore. So instead of calling run over here, we're just going to call it run timeline, and now we don't need to do this for each. We just need to return the timeline like that. Okay, same thing. Now, if you wanted this thing to loop forever, all we would need to do is instead of doing timeline.end, we would just recurse. We would just call timeline again. Let's see if it compiles. It shouldn't actually. Timeline. Now, if this was in a class, it would compile, but as of right now, it complains that this needs to be a lazy val because it cannot access timeline. But if we were actually to copy this out and put it into a class or an object directly instead of having it inside of run timeline, then it would actually compile. But for now, we don't really care. Let's make it a lazy val, and now we should see an endless loop. It's still printing out, and I'm just gonna kill it, and I'm just gonna hope that it dies. It should die. I'm pressing Control C a few times. There we go. It finally died. Let's go into SBT again and try to fix the situation. So in order to fix the situation, we basically need to say, okay, I know that this is a timeline with an infinite recording of events, but I just want to, take just the 2 events. Okay, so what we want to do is we want to take 2 of them, right? So take is a function that we're going to implement in just a second, and it's going to return another timeline. It's just going to cut off everything else. It's going to take 2 events and cut off everything else. Okay, so we're going to have take 2. Now we can run again. It's not going to compile anyway. So it's just going to say that we don't have take defined. Maybe. Yeah, there we go. Take. Cool. So let's go and implement our initial version of take, which we will improve in the next few videos. In fact, the implementation that we have right now, it's going to work, but it contains a bug that didn't allow me to sleep for an entire night. Okay, so it takes an amount and returns a timeline of event like this. And it's also going to be a final def. Okay, so it's going to have a loop, which is going to be a tail recursive function, Scala dot annotation dot tail rec. Let's actually scroll down a little bit. So in the end, what we're going to do is we're going to call this loop with this and 0. Okay, and this is going to be the timeline. So this is going to be the timeline of event. It's going to have some accumulation, which is going to be a timeline of event like this, and it's going to have the count, which is just an integer. Let me create more space like that, and this whole thing produces a timeline of event like this equal sign. In fact, what I started to do recently is this, so that we have more space, so like that, and also like that. Okay, so this is a loop, maybe even like that. Okay, so what is it going to do? Well, it's just going to go to the timeline and it's going to match on it, and if it's end, then it's just going to return ACC, and otherwise, if it's not empty with recent event and previous events, then we're going to do something else. Let me scroll down a little bit. Okay, so if we're going to say if count greater or equal to amount, then we're done. Just return the ACC. Otherwise, we're going to loop again, okay, like this, and we're going to have a timeline, which is going to be previous events dot unsafe run. The next ACC is going to be an entirely new timeline with a recent event and IO pure of ACC, and we'll also have the count, which is count plus 1. Let's see if it compiles. it doesn't because I can't type. Scala annotation Terek. Okay, there's no equal sign over here, like that. All right, it seems like it's going to compile. Let's see what it does. It runs it once. Now, because timelines, they're built like stacks, they're actually built in reverse. And for each, if you remember, there's a fold left behind for each. And what we actually need is fold right, but we don't have fold right yet. And this is why we actually see what's your name printed out last. So what we're going to do now is we're just going to go over here, and we're just going to say reversed like this. And we're going to go and implement this reversed function like this over here. We're going to say final def reversed, which is going to produce a timeline of event. It's going to be like this. Now, in order to implement reverse, we need a bunch of things like our folds. But before we have our folds, let's actually use our good old loops for that. So we're going to have the same structure. We're going to have some sort of loop, which is going to be a Scala annotation.tailrec function. In the end, we're going to call loop with this and end, and loop is going to need the timeline, which is the timeline of event. It needs an accumulation timeline of event, produces the timeline of event like this. Okay, so maybe we should do the same trick as I did before. So I'm just going to press enter over here, and also over here, and also over here. So what it will do, it will match again, same as before. Case end, well, then we're done. ACC, case not empty, create more space like this. Recent event, not reversed, recent event, previous events, and then we're going to call the loop, and the timeline is going to be previous events unsafe run like this, and ACC is going to be not empty with recent event IO pure ACC. Let's see if I made any typos. Looks like I didn't. And there we go. What's your name? My name is Vlad. Now the weird thing though is that we wanted to run it 2 times, but it runs only once. But look what happens if we do 4. Oh, it actually runs twice. Let's do 0. Let's do 1. Let's do 2. Let's do 3. Super fun to work with, right? 4. There we go. Now this is happening because we're producing a timeline which for one iteration produces 2 events. The first event is over here, recent event equals, and the other one is over here, recent event equals. We're going to fix this by the end of the video, but for now we're actually going to revert this to running only once. So over here we're going to say timeline dot end like this, and if we stare long enough at this thing over here, we can realize that this is actually map. So what I'm going to do is I'm going to probably copy this whole thing, comment it out, and then go down over here, paste it over here, and we're going to rewrite this to use map, because no one wants to program like this actually, right? So all of this thing will be gone until over here, and in fact not until over here, that part, right? So we still need the IO pure, but instead of doing this thing, like this is essentially map. So what we need to do is we need to say read map, and the name is going to be over here, and we're just going to print line, and it's going to say my name is name like this. Now obviously we don't have map yet, so let's go and implement map. And what we're going to do it. Okay, we have for each over here, so we're going to put map inside of this. In fact, let me clone that, do that. It's going to be a map over here, and it's going to create a timeline of result like this. In fact, if I throw this exception, it should at least compile. All right, so we're running out of space, but essentially the implementation is over here. So let's do like a bit like this. Okay, so I'm gonna do this match case end equals end, right? So this is basically this case, and otherwise if it's a not empty was recent event, not reverse, come on, recent event, previous events, then we're going to produce a not empty like this, and we're going to say that the recent event is going to be IO pure function of recent event dot unsafe run. All right, so we're not leaking initializations over here, right? So this unsafe run is inside of this IO pure, and the previous events is going to be the same thing, IO pure previous events unsafe run map function, right? Also, you can compare it with for each. It's exactly the same code, but the call to the function is inside of pure. Okay, the same thing over here, right? So that part, right? And then for each map function, right? It's the same thing. Okay, let's see if it compiles. It does, and it runs it only once. Now, since we decided to use IO instead of naked thunks, we might as well use it properly, right? So instead of this, we can just actually say recent event map function, right? Because map on IO is doing exactly the same thing. Okay, so let's do that. Let's see. There we go. And the same thing for the second line over here. It's going to look a little bit weird because we're going to do previous events map, and then for every event we're going to map again to function, right? So this part is essentially the same as this part over here. Okay, let's remove that. Let's see if I made any typos. I didn't. All right, cool. Now, having only map prevents us from introducing a loop again. So if we go down over here, where we're using map, there's no way that we can return another timeline over here, right? But this is exactly what we need. So if we scroll up, we need to return. I don't have it anymore, but what we used to do is we used to call timeline this variable over here. So if you have seen my monads videos, or in fact if you've seen the video in this homegrown collection series when I introduced flat map the first time to you, you can see, you know that map can be implemented in terms of flat map. In fact, they can both be implemented in terms of each other. But essentially, what you can do is, if we have flat map, then we could do this flat map over here, right? And then inside of this, we would create a timeline, not empty, which is going to have the recent event is going to be right, which is basically this. My name is. There we go, right? And the comma over here, and the previous events would be io.pure timeline dot end, right? So now that we have a place to put the timeline, we can actually go and do a timeline over here. But for now, let's not. Let's just do this. Let's do that. And it's not going to compile because we don't have flat map yet. And do we have braces? Yep, that's good. No, that's too much over here, like this. Okay, it should just complain that we don't have flat map. All right, so now let's go and implement flat map. Now we're stealing the implementation from lists, and if we look at our lists, they actually don't have it because lists inherit from foldable factory. And in foldable factory, if we go to flat map over here, we actually see that we're using fold right. We don't have fold right yet, so what we're going to do is we're going to use our good old loops for now, at least for now. But then in the end, we're actually going to see that we actually need something like fold right. So let's go over here. Let me copy the signature of map, because the signature for flat map actually looks pretty much the same. So we're going to do this. So flat map just needs a function that doesn't just produce the result over here. It needs to produce the entire timeline of result, right? This is exactly the place that we needed over here to create it over here. Cool. So let's go and implement it like that. So we're gonna have the similar trick as before. So we're gonna have a loop over here, which is going to be Scala dot annotation dot tailrec. It's going to be a loop, and by the end we're going to call this loop with this and end, and we're also gonna call reversed the similar way as we did in take. Okay, so this loop is going to get the timeline. It's going to get the timeline like this, timeline event, and it's going to get the ACC, which is a timeline of result. Come on, result like this. It's going to produce a timeline of result. Scroll down a little bit, and it's going to be equal to, let's actually put it here. So it's going to be timeline match case and case, and then it's going to be ACC and case not empty was recent event, and previous events is going to be call to loop again. Okay, so the timeline is going to be previous unsafe run, and ACC is going to be another call to another helper, which we don't have yet. So it's going to be called to add many. Okay, and we're going to say over here that many is a function of recent event unsafe run, and the ACC is going to be the ACC. Okay, so let's see if that compiles. It shouldn't compile because we don't have add many. Okay, add many. Okay, 3 errors. Many. Yes, they're all related to many. Okay, so let's have this add many function, which is going to be very similar and also very simple. So we're going to have it over here, def add many. It's going to be many timeline of result like this. In fact, let's do the same trick over here, right? And let's have a comma over here. It's going to have ACC as well, which is going to be a timeline of result, produces a timeline of result, and we're going to do many match case end, then it's ACC case not empty, recent event, not reversed, recent event, previous events. We're going to recurse, so we're going to do add many. It's going to be many equals previous events unsafe. Run like this. ACC is going to be not empty of, let's actually do this, not empty of recent event, and IO pure of ACC. Let's see if that compiles. No, it doesn't, because I can't type 73 function like that. It says, what's your name? My name is Vlad. Awesome. And by the way, I believe this one is also tail recursive. Scala dot annotation dot tail rec. There we go. Oh man, the silly warning. They should fix this, right? If I'm running only one main, I don't care that I have multiple of them. I'm explicitly running only one main. Now, it looks like our implementation is correct, but in fact it is not. And I'm going to show you this was a different example. So what we're going to do is we're going to go and comment this out, and we're going to call run instead. We don't have a factory to create big timelines yet, so I'm going to copy paste a bit of prepared code, which just creates a timeline with 1, 2, 3, 4, or in fact it creates a timeline with 2 timelines inside. The first timeline has 1 and 2, and the other one has 3 and 4. Let's see if it compiles. It doesn't, because in my preparation for the videos I did not have this renaming, so it's not going to be element, it's going to be recent event. And the other thing, the other thing is called previous events. All right, cool. So this is working. So let me show it to you actually. Okay, so this is a timeline of ints, right? So this is ints of ints. So if you collapse it like this is just one timeline. The recent event is over here. The previous events are over here. The recent event is a timeline with 1 and 2, and the previous event is IO pure of timeline of 3 and 4. Okay, so now we can go and collapse it like this, and we can go over here and we can say ints is a timeline of int, which is just ints of ints, flat map identity. Flat map identity is the same as flatten. Okay, so we have flat map identity, and now we're going to have units, which is a timeline of unit, and in which we're going to have ints dot map printline, which looks kind of funny. If we do ints map printline, it looks kind of weird, and it doesn't printline anything. Okay, so now we can return units, and in fact I'm running what I wanted to run is run timeline like this. Okay, so now we see 1, 2, 3, 4. So essentially, flat map identity, it just flattened the ints of ints. So it seems like it's working. So what we're going to do now is we're going to comment this out again. We're going to comment in our example, and I'm going to show you something weird. Okay, so at least in my preparation it was weird. Let's see if it's going to happen now. Maybe I made a mistake. So it looks like everything works normally, but look what's going to happen if instead of Vlad over here, we're actually going to use readline. Readline like this. Look, the behavior is different. It doesn't ask me what my name is. It already asks me for the name, right? So I can type something in, which is going to be read, by the way. I press enter, then the same thing continues. Now, this is happening because there is one tiny by name error is missing that is usually not present in the regular signature for flat map. Let me go over here to flat map, and where is it? Flat map over here. So this event over here, if you make it by name like this, then all of a sudden everything works again, right? So it asks me, what's my name? I'm saying Vlad. Cool. There's another issue as well. Let me actually, in fact, I'm going to leave it like this. So there's another issue as well. If we actually start recursing again, okay? So we have the take 4 over here, so it shouldn't go like forever. So let's go over here and let's do a timeline. Let's see what's going to happen. There's a Stack Overflow. There's Stack Overflow over here because we implemented flat map in a sort of fold left fashion, right? Because we have a tail recursive loop. Tail recursive also means that there is a fold left behind it, and then we reversed it. right? And our implementation was these loops. Okay, so we have flat map, which has add many, which is a tail recursive function. Let me collapse it as well over here. Another loop over here, and then we call it, and then we're reversing it, right? But we can't reverse an endless stream. And in this case, it feels like it's an endless stream. So in fact, we actually do need fold right, and we will modify the signature of fold right to accommodate for this by name error. Now, first let's revert the change. Let's go over here. Let's do that. That should be relatively fine now. Blad. Let's also put blad back in. Where is it? Where is it? Where is it? Over here. Okay, so that's just going to be blad like this. So now it runs faster. So now let's go and implement fold right. So let's go to foldable, and copy the implementation of fold right. I'm sorry, the signature of fold right. Let's go and let's put the folds above the for each over here. Right. So let's do fold right over here. It's going to be a final def, and we need to add this arrow for the event, right? So the element is going to be event like this, and it needs to be by name like that. Okay, so now we're going to have equals, and the implementation should be exactly the same as in list, for example. So if you go to list, and we're going to see fold right over here, let's just copy the whole thing like that, and let's go here, press enter. This match. Okay, so empty is called end in our case. Then we're going to return seed. Non-empty is called. Okay, this is actually kind of cool. We can do this event. Okay, so now this is not other events. This is previous events like this. And I believe we just need to go over here and we need to say dot unsafe run over here, and also unsafe run over here, unsafe run like this. Let's see if it compiles. Yep, it does. So now all we need to do is we need to make flatmap use the fold right. Okay, so for this we can go to foldable factory, and we have our flatmap over here. So we're just gonna copy that thing. Let's go to flatmap. All right, let's take the whole thing over here like this, throw it out, paste it in. Okay, so this thing is a timeline. We don't have factory empty, we have just end like this, and we also don't have add yet. So what we're going to do instead is we're going to create it manually, so like this. So we're going to do non-empty, and we're going to say recent event equals IO pure of current, which is exactly why we have this by name parameter over there, right? So the current in fold right, which is over here, it's this event. It's a by name parameter, and it's the by name parameter exactly for this reason, so that we can put it inside of IO pure, so it's not evaluated before that. Okay, so we're gonna do previous events. It is IO pure of ACC, and ACC was a by name parameter even before that. Let's see if that compiles. Yes, it compiles, and let's go back to our example, which is our playground over here. And now let's see if we can run it endlessly, timeline like that. And yep, now it works. It now works with 4, it now works with 6, and so on. Let's go back to 4 like that. Now the next thing that we're going to do is we're going to improve map, because map can also use fold right. So if we go to foldable factory, we have our map over here. We're just going to copy it the same way. I'm gonna go to map, which is over here, throw the whole thing out, just paste that. That's timeline, that's end, and we don't have add yet, so we're gonna do similar trick as we did over here like this. So this is going to be IO pure of function current like that, and yeah, I believe that's it. Cool, still works. I mean, we're not using map right now, but you know, it compiles and still works. Now, it would be kind of cool to have this add function, and also our code in playground, which is over here. It still looks kind of weird. Nobody wants a program like this, right? It's so much code, even though we're using flat map over here. Okay, so what we're going to do is we're going to implement the add function, and there is a problem with the add function. So for example, let's see. So if you look at this, so instead of this, we would like to be able to write something like this. So read line should be some timeline, which is in this case is timeline end, right? Add this thing. Okay, so this is what we want to write instead of this whole thing. There's a problem though. The problem is that this timeline is not evaluated yet, right? So we're passing it into IO pure. But over here, if you're saying dot add, the way the object orientation works is that this thing it needs already to be evaluated. Right? So we can't just put this add function inside of the timeline class. Fortunately, there is a way to do this, and this way is going to be the extension method pattern. I just coined it to be a pattern, and I'm going to demonstrate this to you with the IO monad. So let me throw this out for a bit like this. So if we go, what are we going to do? First of all, we don't need this timeline anymore. Right, let's comment this thing out. Right, so let's just go and say run over here. Let's see. All right, cool. So what I want to have is implicit final class any ops from HGC takes a self of a, and it's going to have a final def IO of a equals IO pure of self. Now notice that self. Notice that self, it is already evaluated over here, right? So if we create an IO pure of self, but self is already evaluated, so there's no point in creating a pure. So let me demonstrate this to you. So if we print it out high, and then we're saying IO on it, what should happen is that it shouldn't be printed out at all, right? So the behavior should be the same as doing IO pure print line high, right? So in this case, nothing is printed out. So I want to have exactly the same thing over here, right? And in order to do that, all I need to do is I need to have an arrow over here. Right, so now it looks like the thing that we're calling the dot on is not evaluated yet, and we're going to do the same thing for the timeline. So I'm gonna do this, and I'm gonna copy that. I'm gonna throw this out, and I'm gonna go do this like that again. Let's see. Okay, it runs 2 times. Okay, so I copied it out, and I'm gonna go into our object over here, and right under here, I'm going to paste that in. It's not going to be any ops from HGC. It's going to be timeline ops. It's going to be timeline ops, right? So instead of IO, we're going to have add over here, right? And by the way, this is not going to be just an A, and in fact, it's not going to be an A at all. So this is going to be event, and self is going to be, I'm going to call it timeline. Timeline of event. Okay, let's create a bit more space. Like this. So we're going to have final def add, and we're going to do this covariance trick, super event, and what we're getting is some sort of input, which is super. So we need the by name parameter as well, because we also don't want this one to be evaluated. So we're going to have over here a timeline of super equals not empty, and we're going to have recent event equals IO pure of input, right? So this is why we needed this by name parameter, and the previous events equals IO pure of timeline, and this is why we needed this by name parameter. Okay, that's cool. Let's also create a bunch of aliases. So let's go over here. Let's create an add inline final def. It's going to be called prepend, and it's just going to call add with input. Okay, like this, and let's create one more. Let's call it after. Let's call it after, like this. Okay, so now, for example, we can go into our flat map, right, where we have that thing commented out. Okay, so we can do ACC at current, like this, right? We can also do after current if you wanted to. Right, but we're not going to. So we're going to do ACC at current. We're going to go to map, same thing, right? So now it actually works. Awesome. And so now what we have is, if you go to our playground, what we can have is, okay, let's see. So instead of this, we can actually just say timeline.and after read line like this. Okay, so let's throw this out. That's super cool. What's your name? Vlad. Awesome. Vlad again. Awesome. All right, so let's have over here io.pure Vlad like this. I'm sorry, I don't need to do this whole IO thing anymore. Just do this like that in a string. Okay, awesome. And now what I can do over here, instead of creating, so over here we're creating just one single event, so to say, right? So we're creating one non-empty thing. So instead of this whole thing, we can just do something more awesome instead. So we can take, for example, the read, right? We can just call, we can call flat map on it. Flat map on it. There's going to be a name, right? So what's happening inside of flat map? Well, yet another timeline is being created. Okay, so we can do the same trick. We can just say timeline, which comes from here, right? So this timeline is going to be after what? Well, after this this right, which is going to be just print line of this, like this, and this entire thing is going to happen only after we're going to have this, right? Only after this. Okay, so let me remove all of that stuff. Let me see if I have made any typos. It looks like I didn't. It behaves exactly the same way. Our code is becoming shorter, but it's still kind of weird. In fact, we could inline it the same even more, right? So instead of read, we could, for example, do this, right? So now we don't even need the read. So we can do timeline and after Vlad. So it looks kind of cute, but the control flow is so obfuscated that it's not really obvious what is happening before what, right? So you see, okay, what's your name? And then you see my name is what, but where is the read? Oh, the read is somehow there. It's weird. Now it would be more awesome if we could create timelines the same way as we're creating lists with these the right associative operator. So if you go to list and if you look for this method, not this one, hold up, this one, right? So if you could add like this, right? So the same add, prepend, and this one, then our code might look actually a bit more. And it's common for streams to use this symbol. So this is what we're gonna do. So I'm gonna go to to our timeline over here. So we're going to copy that and going to paste that over here, and we're going to call it like this. Okay, like that. So what we can do now is we can go to our playground and rewrite it the following way. Let me duplicate that. So what we can do is we can say, okay, so print line, what's your name? Which is the first thing, which is why it's written as the first thing. Then we're going to prepend that to read line, prepend it to timeline.end, right? And only then we're going to do this flat map thing, right? Only then we're going to do this flat map thing, and this flat map thing can also be written to this print line like this, timeline. Okay, there we go. Remove that, and if I did everything correctly, it should compile, but it should not be green. Yes, it is red. So it says, what's your name? I'm going to say Vlad. My name is Vlad. Vlad again. My name is Vlad. So everything is red, and this is happening because there is a limitation in the Scala compiler. In fact, if we look into the standard library, into the current streams in Scala 2.12, then we will see that they use exactly the same operator, and over there it works. And I believe over there it works because the streams in the standard library, they don't have their first parameter, the recent event, as a binary parameter. So the recent event in the streams, it is always evaluated. So if you're creating a stream of 1 to 3 in the standard library, then the 1 is already evaluated. Okay, and in fact, it is being deprecated in Scala 2.13 and is being replaced by a new data structure called lazy list, which is basically a stream. And for lazy list, the first element is also not evaluated the same as we're doing it. And I believe that the Scala compiler team, the standard library team, they have been faced with the same challenge as we, and so they improved the Scala compiler. And as of right now, I'm recording this video in the beginning of June 2019, and Scala 2.13 release candidate 3 is already out, and the libraries are slowly being published. So because we're not using many libraries, we can actually already start playing with it, and this is what we're going to do now. I'm going to go to our build file, and we're going to switch from 2.12.8 to 2.13.0 RC3. What's happening to my voice? I'm talking too much. 0-RC3. 3. It came out actually yesterday. In fact, we might as well clean up our build a little bit. So over here we have the initial comments and console import homegrown collections, but we actually also have the homegrown math library. So let's do this like that and like that. No, just 3 of them like this, like that, and let's copy that. Math library like this, strip margin. What else? I had problems getting continuations to work, and we still have them laying around over here, so I'm going to comment this out for now. What else? So Scala test, the 305 is not published yet for RC3, but there is a special version that is published yet, so it's the 308-RC5. Scala check, in fact, is published. The continuations don't really work, so I'm going to comment this out. We stopped using simulacrum at some point. In fact, I believe I introduced it to you, but then we didn't use it anymore, so I'm going to comment this out. I'm actually going to completely remove it. What else? So as I said, continuations don't really work right now. Paradise. We needed this paradise just for macros, I believe. So we actually don't need this. So let me throw this out. Okay, I believe in fact that this is all that we needed. Yeah, 213 RC3. Change the version of Scala test. Remove the continuation stuff. All right, let's see. So if we reload, okay, and it never hurts to do a clean every time you do something like this. So let's do clean. Now I already know that the continuations are not going to work, so I'm going to go to cps.scala. I'm just going to comment out the whole thing. And if I am right, then there should be only one thing that doesn't compile as of right now. So if you go to like while it compiles, I'm going to go to foldable. So they removed traversable. So traversable is now called iterable, which is over here, right? I believe, or no, it's actually deprecated. But what we need to do is we need to go and override another method over here. So we need to say final override def iterator, which is an iterator of event, and we're not using it as of right now, so we're just going to do this like that. Okay, so let's save it, and it's still compiling something. Compiles the bridge for 213, took 21 seconds. All right, so this is exactly, this error was exactly what I was just fixing. It's not event, it's element like this, and the rest should actually be fine. Which also shows you that it's always good to have tests, even if just for regression. So if everything turns green, then our code actually works for Scala 213, and it should. Let's see, compiling 12 Scala sources into a test. So these are already the tests. So it should be finishing, doing that now, and running the tests. Progress. There we go, all our tests are green. So now if we go back and run our playground like this, then everything is green now, right? We just changed the version and now it's green. Before it was red. So now we can actually go and let me close this, let me close that. We don't need the build anymore. We don't need the list. So now we can go and we can improve the map and flat map and so on. So everywhere where we say add, we can actually go and use it over here. So we can do current ACC like this, and behaves the same way. In fact, I should probably put in Vlad over here like this. All right, what's your name? Vlad, whatever. Okay, run again. Yeah, okay, cool. So now this is much better because now the order of current and ACC is the same. So now instead of this, we can just do this and that like this. Do that. That should be an underscore, obviously. Okay, so now this is shorter, and a similar thing over here. So we can just do underscore this function. Did I type it right? Function that. Like this. Oh my god, that's exactly the opposite. So it should be, this one should be on the left like this. Current like that. There we go. All right, let's see what we can also do. If we go to reversed, I believe, This is head, tail. Where's reversed? Yeah, over here, for example, and what is it? This is take. Instead of this line, we can actually go and say recent event, unsafe run, ACC. Okay, I believe that this is, more beautiful. Reversed, it's going to be probably a very similar thing. Comment and this out, go over here like that. It's going to be a recent event, unsafe run, and ACC like this. I believe that these are all the places that I wanted to touch. Let's see. Yeah, I believe that these are all the places that I wanted to touch. Now we can improve the situation even more if we introduce a factory. So if we go to list, there will be an apply somewhere, which is over here. So we can just copy that. Okay, we can bring it down over here. So let me collapse that. Let me put it over here, for example. Okay, so element is called event. This one should be small. In fact, this one should be called recent event, and it should say unsafe run. Okay, recent event, which is over here. Now this should be a by name parameter over here, and this should be not other elements. It should be other. No, it should be previous. In fact, in this case, this is not previous events. This is following events. Following events. Okay, and we're gonna do a fold right, and we need also unsafe run over here. Unsafe run over here. Now we need unsafe run over here because these following events, they need to become IO of event because Scala does not have var args for a by name parameter over here, so we can't do this. So we're forced to do something like IO over here. Right, so essentially the first element is going to look cool, but all the other elements we're going to have to put them into IO. And it's not called empty, it's called end. And it doesn't produce a list, it produces a timeline. Timeline like this. What else? Okay, this is whoops, this is that, and this is that. Can we create even more space? I believe no. Okay, like this. All right, what else? Oh yeah, we actually don't need unsafe run over here. Right, there we go. It overwrites nothing. Final def apply. All right, now it actually fits into one screen. Now in our case, it's actually really cool because we're creating a timeline only with one event. So we can go over here into our playground and let's see over here. So this is a timeline of one event. So we can just do timeline of blah like this. Same thing. Now, even though we're creating a timeline with only a single event, what we're going to do now is we're going to overload the supply with a bunch of other factories that are going to help us out in the next video. So what I realized is that even though we cannot have var args for name parameters, we can actually overload apply with a bunch of versions. So we're going to have a version which takes only one element. We're going to have a version which takes two elements, all the way up to 10. And then the one with the 10, it will also have as 11, 12, 13, and so forth. It will have the same thing over here. Now this is a lot of typing, so I'm gonna just copy paste it from my script and like this. All right, copy that. Let's see if that's going to work. Paste it over here. Let's see if it compiles. All right, it compiles. So let's go through them real quick. Okay, so this is the one that it takes only one parameter. And by the way, I have no idea why the compiler is not complaining, because you know, this signature, it looks pretty much exactly like this signature, right? Because it can be 0 parameters. So somehow overloading of this worked out. So if you're passing one element, then it just does this first, prepend to timeline end. If you have two, then it just does first, prepend to whatever, apply second, which is going to be this, and then so on and so on. Okay, so apply second, third, apply second, third, fourth, blah, 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 all the way up to 10. All the way up to 10, and then in the last one, we're going to create all of them like this, and then we're going to prepend all of them to this. We're going to improve this in just a bit because this is essentially already a timeline, and we want to prepend this timeline to this timeline. And so in order to do that, we're going to go to list. I'm going to go to list, and we're going to copy this function, right? So we're going to copy that, right? And we're also going to put it into our extension, which is over here collapsed. Okay, so we're gonna go over here. I'm gonna paste it over here. All right, so let's see. So this is not element, this is actually event. We don't need lists, we need timelines like this. And we need that, I believe, and that should be it already. Of course, we don't have this because this is an extension method now, so it's gonna be timeline. Okay, like this. Okay, so I'm gonna call this one add many. Right, so we're gonna have like the same kind of overloads. Okay, so we're gonna have add many. I'm gonna duplicate that, bring it down, and it's gonna be called prepend many. It's gonna be an inline final def. The implementation is just gonna be add many that, and we're gonna have also after many, and we're gonna have also these three columns. Okay, so now that we have these 3 columns, we can go down over here, and now we can do first and then like this. So this is going to be called to apply, and all of these guys are going to be commas now. Commas, and now over here we can do the third one. Okay, so we're prepending the first to a bunch of these, and then we're gonna have what's missing. Oh yeah, I probably called it just with 3 columns, and now it was this. Okay, so we're gonna have this over here, right? So now this should work. Okay, we obviously don't really know if it works because we wouldn't have a test for this or anything, but now we can go to our playground and actually use it over there so that our code looks even better. So for instance, instead of flat map, we can just say map, and then we can just cut this out and put it over here and do it like that, right? So this way it looks a bit more, visually more corresponding to what is actually happening. So if you read it top to bottom, it's going to be what's your name? It's going to be Vlad. My name is Vlad, and then do the same thing again, right? So it's sort of like, left to right, top to bottom. It's a bit more clear. And we could even separate this a little bit. So for example, we could do map, and name comes in, and this string interpolation thing comes out like that. Okay, and now over here we just need to map to print line. Okay, so this is exactly the same code. Monad laws allow us to do this this sort of thing. And lastly, since we're dealing with pure values, we can actually have our vals again. So we're gonna have val read, which is going to be a timeline of string, which is basically just that. Okay, so this is our read, and our write can look a little bit different now. So for example, it's going to take an input, which is going to be a timeline of string, and it produces a timeline of unit, right? So we're basically hiding IO inside of the timeline, and what we're going to have here is going to be input, and then the rest is going to be copied from over here, like that. Right, so this is a very specific write, only for this example. Okay, so we're gonna do this like that, and now we can go and we can refactor our timeline. So we can say print line, what's your name, and then instead of this whole thing, we can just say write read. Okay, I believe I did it correctly. Yes, I did. By the way, it's been a long time since we actually used it with a read line. Let's see if it actually works. Yes, what's your name? Vlad. It's still Vlad. Let's also do it 2 times. Vlad. Right, so everything still works the same way as before. Let me put my name again over here, but this time, at this moment, you probably are tired of hearing my name. Now, one thing that we need to be careful with is that we need to treat the timelines always in such a way as if they were infinite, which we're not doing in this case. So for instance, if I do this, in fact, in this case, I'm going to do a read line again, right? If I make it infinite again, right? So if I make it a lazy val, right? So it's just going to keep doing the read line. Look what's going to happen. It's going to say, what's your name? Vlad. My name is Vlad. But now it's not asking me what my name is again, right? It wants me to type stuff, right? So it repeats only one part, and it ends after 4. Okay, so if we do take 3 over here, let's see what's going to happen. Right, Vlad, my name is Vlad, and then it just waits. Vlad, enter, my name is Vlad. So in this case, it sort of worked, but what's her name is missing. So now obviously we could fix it a little bit, right? For example, we can go over here and we can say, just take 1 again. Okay, so now it's going to behave the same way as before. I mean, if we have a 4 here, right? So what's your name? Vlad. What's your name? Vlad. Okay, so now behave the same as before, but there should be a better way. Also, it's super weird with these takes. Like there's one take in the middle, and there's one take over here. And before, you know, the regular imperative solution and also the regular functional solution was IO. There was a number 2 somewhere in there, and over here there is a 4 all of a sudden. We need to be able to fix that as well. Now, for this, we're going to implement yet another function, and I know that this video is getting way too long. This function is called zip. In fact, we don't have it for list, but we should. So if I open a regular terminal and I go into Scala over there. So if you're not familiar with zip, it basically fuses two lists together. So if you have list 1 to 3, zip with list of A, B, comma C, close this one, then what you see is the zipped version, right? So now it's a list of tuples with 1A to B, 3C. Okay, and you can also do unzip, right, which gives you back a tuple with 2 lists. Okay, a list of 1 to 3, a list of ABC. And if you don't have enough elements in either of those lists, then they will be just cut out of the result, right? So now the 3 with a C is missing, and this way, if you miss the C over here, right? So if it's missing on either of the ends, then it's just going to be cut out. And this is what we're going to do. We're going to implement it for our timeline real quick. So we go over here, and somewhere at the top, okay, so we have head, tail, fold, right for each map, flat map take, reversed, and let's go over here and implement zips. So we're going to have final def zip, which is going to have that event. It gets that, which is a timeline of that event, and it produces a timeline of a tuple with the event and that event. Okay, like this, and it equals this match case end, then it's going to be end. If it's not empty, recent event, previous events, like this. Now in this case we need to pattern match on the second one, right? So we're going to have that match case end. So if they're both empty, then it's also going to be end, and if it's not empty, then we have that recent event and that previous events, like this. What we're going to have over here, let me create more space like that. Let me scroll down a little bit. Now what I'm doing right now, I'm actually planting a bug for the next video, but for now it's going to work out well for us. So we're going to have a head, right, which is a tuple. So it's going to be recent event unsafe run into that recent event dot unsafe run, and we're going to have a lazy val tail, which is going to be the same thing for the previous events unsafe run, zip with that previous events unsafe run, and in the end we need to construct a timeline with event and that event. Okay, so how we're going to do that? Well, it's just going to be head prepended to tail, like this, right? So now we have zip, and I forgot to put in my name again. It's not cool. Come on, let's go down. Let's do in fact, maybe it's actually not such a bad thing. I'm just going to press enter 2 times. All right, there we go. So what we're going to have now is I'm actually going to comment it out and copy it and paste it over here. And we're going to have something slightly different. So what we're going to have is lazy val timeline over here. I'm just going to throw it out like this. So what we're going to do is we're going to have questions, and we're going to map the questions to print line. Right, so I'm gonna finish writing the rest in a bit. So I'm gonna have over here lazy val questions, which is a timeline of string equals. Let's scroll down a little bit. It's gonna be what's your name? What's your name? Like this, prepended to questions. Okay, so we're gonna have again questions map print line, and then we're gonna zip it with read. Read looks exactly the same as over there. In fact, maybe we should put read down there. So we're gonna have questions, and then we're gonna have read like this. So the next thing that we're gonna do is we're gonna do map. Okay, so now we're going to have a tuple with a unit that is already applied, right? So this underscore it already ran. It sort of looks like the for comprehension with IO, and now we have the name that comes from read, and we're just going to map it to name over here, and we're going to do the rest, which is map. The rest is basically this. The rest is basically that. right? And if you remember before, we were attaching this to timeline. Okay, so we don't need the right anymore. All right, so we have questions map print line. Zip was read map to, this was the print line was what's your name. This is the input was a name that comes from the read. Then we're gonna map it. We map to print line, attach it to the timeline again, and I believe this should be enough. And because now we're fusing two events into one, we can actually do two over here, and it should work exactly as we want, right? So it just runs it 2 times. Vlad, Vlad. 2 times. Now, one of the very last things that we're going to do is we're going to have a more formal way of consuming all the events, which is also called draining, because remember, streams are, they're related to water. And if you have a sink, you can drain the whole water into the sink. So instead of calling for each with identity, as we're doing at the top of playground over here, instead of this, what we want to do is doing something like this, drained, right? It's also called forced, and it's also called to list, because basically what it will do, it will just create a list. So let's put it under zip, which is over here, I believe, right? Like this. There we go. Okay, there we go. Okay, so we're going to have final def forced, which is just going to return a list of events, and it's going to do just fold right, list of event, list.empty, whoops, list.empty, and just gonna do that. Okay, so this is gonna be forced, and we're gonna have at inline final def drained, which is a list of event, which is just gonna be forced, and we're gonna have the same thing again, and it's going to be forced, and this one is gonna be called to list. Okay, so it's exactly the same code, inline, okay. There we go. Vlad. All right, now I know that this video was way too long, even longer than my usual videos. But since I'm in a good mood today, we're also going to implement one more function which is similar to zip, and it's going to be called interleave. So interleave super event that timeline of super, like this, and it's going to create a timeline of super. Okay, so what interleave will do is it will take 2 streams, and it will take one element from one stream and then from the other, and then from this stream and then from the other, right? So it's just going to alternate between them. Maybe it should be called alternate instead of interleave, right? So it's going to be this match. So if this one is empty, then we're just going to return that. And otherwise, if it's not empty, then we're going to have recent event, and we're going to have previous events. Then we're going to do recent event dot unsafe run. I'm going to prepend that to that interleave with previous events dot unsafe run. Okay, now what this allows us to do is it allows us to do something really cool. So if we go down over here, so now we can have alternative questions. So I'm gonna just copy that, I'm gonna paste it over here, and we're gonna have alternative questions like this. Okay, so instead of saying what's your name, let's say what's your full name. Okay, like this. And so what we can do now is we can go over here, instead of doing questions map print line, what we can do is we can do questions interleave with alternative questions, and only then print line. Okay, so let me press enter a few times. All right, so let's go. Okay, what's your name? My name is Vlad, but what's your full name? Well, it's actually Vladislav, it's not Vladimir. All right, what's your name? Vlad. What's your full name? Vladislav. Like this. It runs only 2 times. Why does it run only 2 times? Oh yeah, we wanted it to run only 2 times. Okay, so but if we want to do 4 times, Vlad, full name, Vladislav, Vlad, full name, Vladislav, which is really cool. So as I said, working with streams is actually super fun, but actually implementing them is annoying as hell. Okay, so this actually looks super cool. All right, as a reminder, nothing is perfect. Streams, they look super awesome and super cool, but they have downsides as well. For instance, every tiny by name parameter that we add has a performance cost, and also if this was a production grade library, then it would need to be trampolined properly, right? Because every time we keeping going, then the stack trace keeps growing. The same thing with the IO monad. It needs to be properly trampolined, but we're not going to do this over here. First of all, because I already have videos about trampolines and I still have nightmares about them, and secondly because it would just make everything even more complicated than it already is, and it already is complicated, and we're gonna finish this implementation in the upcoming videos, and it's going to become even more complicated. So we definitely not going to do trampolines. All right, so all that's left to do is to commit what we have right now, and we're going to stick to Scala 213. So I'm going to go over here. I'm just going to commit everything. So we're going to do add everything and commit -am, and this is video 30, which is streams, and like that, and push and unlock my key. Like this, it's been pushed, and let's check it out. I started to use workspaces in Windows, so I just switched to another workspace, which is in Windows. So if I go right, I'm inside of the VM, and if I go left, I'm inside of my Windows again, where I have this already prepared. I go to my commits, streams, and let's see what we did. So we changed the build file. We changed to 213. Removed CPS, removes simulacrum, commented out the whole CPS thing. What else? In fact, we don't need this. Don't want to, yeah, unpin the sidebar like this. All right, so we went to foldable, edit this iterator. We're actually going to have an implementation for this iterator in one of the next videos. So we have IO, super tiny, simple version. We have our playground with a bunch of commented out stuff, and we have our streams, which are called timeline, with head, tail, fold right, for each, map, flat map, take, not empty, not empty? No, take, reversed, zip, interleave, forced. And yeah, we have a bunch of factories. By the way, in the standard library, you don't even have factories like this, right? So if you say lazy list was 1 to 3 and so on, then they will all be evaluated, right? So the var args thing, doesn't exist with a binary parameter, and they didn't do this crazy overloading thing as I did. That's pretty much all I have for you today. As always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you find my videos valuable, consider supporting me on Patreon, and most importantly, take care.